When you rub a balloon onto your hair, the hair tends to stick to the balloon. Why do you think this happens? Well, this happens due to the force of electricity. And to understand this force of electricity, we need to understand something called charge. And that's what we'll do in this video. And to understand what charge is, we need to recall that if you take anything that you see around us, like for example, this cat, and if you were to zoom into any of its part, like say its tail, you'll find it's made of different organs. And then if you zoom in even further, you'll find it's made of cells. And if you were to zoom in even further, then we would see that it's made of atoms. The word atom literally means indivisible. So the idea is that everything that we see around us are made up of these tiny, indivisible building blocks that makes up everything around us. But after the 1900s, we realized that atoms are not really indivisible. We found out that even atoms are made up of even smaller particles. And we have named them today. These smaller particles that even make up the atoms are called the protons, the neutrons, and the electrons. And almost all the atoms are made of these three particles. And to understand what charge is, let's conduct an experiment in our head involving these particles. So let's do a thought experiment. If we were to keep two protons close to each other, then we would find for some reason these protons repel each other. They push each other away. Similarly, if you were to keep two electrons close to each other, same thing. They push each other away. They repel each other. However, if you kept a proton and an electron close to each other, then you would find that they attract each other. And now we may wonder, well, what's causing these protons and electrons to attract and repel each other? And people thought, or people guessed, that maybe, just maybe, these protons and electrons have something that's causing this. And that something that the protons and electrons possess, because of which they are repelling and attracting other protons and electrons, is what we call as charge, or more formally, electric charge. So let's write that down. That is what we call electric charge. And this force that exists between these charged particles is what we call as the force of electricity. So long story short, if somebody asks, what's electric charge? Then it's simply something that protons and electrons possess, which causes them to attract or repel other electrons and protons. And now we can investigate this electric charge even further. If you look at this experiment carefully, you notice that if you take like particles, they repel each other. And the unlike particles, the different particles, they attract each other. So that made us guess that maybe the protons have one kind of charge and the electrons have another kind of charge. And so the kind of charge that the protons possess, we simply named it the positive charge. So this is also a positive charge. And the kind of charge that the electrons possess, we named it negative charge. Negative charge and negative charge. And as a result, like charges repel each other. Unlike charges attract each other. So protons are positive, electrons are negative. Now, what about neutrons, you may ask? Well, it turns out that neutrons do not participate in any of this force. If you were to keep a neutron close to a proton or an electron, or even close to another neutron, we will find absolutely no force between them. From this, we can guess maybe neutron doesn't have this thing called the electric charge, and so it's neither positive nor negative. And so we like to say it is neutral particle. Its charge is 0. And in fact, that's why it's even called neutron, neutral particle. And if you look at an atom, what about an atom? Do you think an atom is charged particle? Well, we might guess, well, yeah, because it's made up of charged particles, right? But turns out that every single atom has equal number of protons and electrons. And because protons are positive and electrons are negative, the total charge on the atom therefore will always be 0. So even atoms turn out to be neutral particles. For example, if you take a hydrogen atom, it has 1 proton and 1 electron. So 1 plus, 1 minus, together you get 0. If you take, say, a carbon atom, it has 6 protons, 6 electrons. Again, 6 plus, 6 minus, together 0. So atoms are also neutral. And that's the reason why most of the stuff around that you see are electrically neutral, because they have equal number of protons and electrons. And that's the reason we don't get to see this electric force in action at large distances or on large objects. That's mostly because things are normally neutral. However, when you rub this neutral balloon on this neutral hair, turns out that due to friction generated, some of the electrons from the hair get transferred into the balloon. And now since the atoms of the hair has lost some of the electrons, it has extra protons. And as a result, the hair is now extra positive. And similarly, because the balloon has gained electrons, the atoms of the balloon, or the balloon itself, has now become extra negative. And because of this positive and negative attraction, we see the hair standing up. So the force over here is exactly the same as the electric force that we find over here. Amazing, isn't it?